Hello, geometry students, and welcome to lesson 10.6, part 2, circumference and arc length. We're going to start with the circumference of a circle, which is the distance around the outside of the circle. It's almost like the perimeter of a polygon, except a circle is not a polygon, so we call it a circumference. The number pi is the ratio of the circumference to the diameter. Oftentimes we can abbreviate pi with 3.14, or we'll just use the pi button in our calculator. Sometimes we'll just leave pi in our answer, and that would be called leaving our answer in terms of pi. The circumference, or the distance around the outside of the circle, is pi times the diameter, or the circumference is 2 pi r, because you would have to double the radius and then multiply it by pi. Circles that lie on the same plane and have the same center are called concentric circles. So here we'll take a look at this example. It says a car has a turning radius of 16.1 feet. The distance between the two front tires is 4.7 feet. In completing the outer turning circle, how much farther does a tire travel than a tire on the concentric inner circle? So what we'll do is we'll find the circumference of the outer circle and the circumference of the inner circle and just subtract it to find how much farther the outside tire travels. So let's see outer. So the circumference is equal to 2 pi r, which is equal to 2 times pi times 16.1, which would then be 32.2 pi. That would be in feet. So that is the circumference of the outer circle. Then let's find the radius of the inner. Radius of inner is 16.1 minus 4.7. And we get 11.4 feet for the radius of this inside circle. So now let's do the circumference of the inner is equal to 2 pi times 11.4, which then becomes 22.8 pi feet. So then if we go over here, we can subtract the outer circumference minus the inner circumference and get 9.4 pi, which is about 29.5 feet more distance the outside tire travels than the inside. This is what's called leaving your answer in terms of pi. Okay, the measure of an arc is measured in degrees. That was yesterday's lesson. While the arc length is a fraction of a circle's circumference. An arc of 60 degrees represents 60 out of 360 degrees of the circle. So if we reduce 60 divided by 360, that gets us 1/6 of the circumference of the circle. So an arc length is a fraction of the circle, of the circle's circumference. So here it says the length of an arc of a circle is a product of the ratio of the measure of the arc out of 360 and their circumference of the circle. So we can say here that the length of arc AB is equal to the measure of AB divided by 360 times 2 pi r, or that would be pi times diameter, depending on if they give you the radius or the diameter. Look at this example on the next page. It says to find the length of each arc shown, leave your answers in terms of pi. So we're trying to find the length of x, y. So we are going to take the measure of x, y, put that over 360 to find what fraction of the circle's circumference, times, here's the circumference. So we know that the measure of this arc is 90 degrees. So we have 90 degrees divided by 360 degrees is equal to times pi times diameter. 90 divided by 360, the zeros cancel out. 9 out of 36 is 1/4, so we have 1/4 of 16 pi. Can simplify, you get 4 pi. So the length of this arc is 4 pi inches. Now we're going to find the length of arc XPY. So while this was a minor arc, minor, now we're going to find the length of this major arc. So we have the measure of arc XPY divided by 360 times, in this case it's 2 pi r because they give us the radius. So it tells us that this is 240 degrees, so 240 out of 360 times 2 pi times 15. Okay, 240 and 360, the zeros would cancel out. You'd be left with 2/3 when you reduce that, times 30 pi. Over here, 3 goes into 30 10 times. 10 times 2 is 20. So you get 20 pi, and that is in centimeters. So that arc is 20 pi centimeters long. Here it says to find the length of a semicircle with a radius of 1.3. So a semicircle has a degree measure of 180. So we're going to do 180 divided by 360 times, and this is a radius, so 2 pi of 1.3. Well, 180 out of 360 is 1/2. Then 2 times 1.3 is 2.6. When we reduce that, half of 2.6 is 1.3 pi, and that is meters. Last but not least, is it possible for two arcs of different circles to have, it is possible for two arcs of different circles to have the same measure but different lengths. Okay, because you could have, for example, okay, so let's just say that's 45-degree angle. Oops. Then you could have bigger one, but still be 45. So they both have a 45-degree measure, but because this is a bigger circle, it's going to have a larger circumference than this one. It also says it is possible for two arcs of different circles to have the same length, okay, but different degree measures. Congruent arcs are arcs that have the same measure and are in the same circle or in congruent circles. Okay, so that is it for today. We are done with 10.6.